So I'm sure you noticed a few different things around here. It's snowing outside, and rather than stay in and stay warm like a sane person, I decided, hey, I bet that park I like to hike at is practically empty. So, anyway, I thought that I'd talk a little about philosophy of science. It seems like most people just assume, like Karl Popper's idea of falsification is just kind of assumed to be the very obviously correct way of doing science. I mean, many scientists take it for granted that science means that scientific theory means something that's falsified. And most people don't think as much about Thomas Kuhn. Now, Thomas Kuhn coins the term paradigm, and people often New Age people particularly like to throw around that term without realizing what it means. But what it is it's in large part a rebuttal to Karl Popper's theory. So, what it is basically, there was an interesting anomaly in Karl Popper's theory about falsification. That was evolution. Popper himself admitted that evolution was not falsifiable, and yet still felt it was important because he was a person with great respect for science, and like any person who's examined the evidence, believed in evolution because there is evidence for evolution. It would be hard to falsify evolution, and some people have said, okay, evolution would be falsified by, say, rabbits in the Cambrian, or a crocoduck or whatever they got. But I don't think that scientists would suddenly abandon evolution if things like that were discovered. It would be considered an anomaly, and they'd try to go explain the anomaly. Like, interesting, rabbits evolved at a much earlier stage than we thought. Therefore, we'll have to rethink the evolutionary pathway of the rabbit. So, yeah. So it's always adjustable to whatever evidence comes around. Or if it doesn't adjust, then the countervailing evidence is not treated as falsification; it's treated as an anomaly, as it should be. And that's the thing is, Karl Popper, the falsification applies to minor things. Usually, when a scientist comes with a new hypothesis and they want to test it, and then the experiment fails to confirm the hypothesis, then they're like, okay, it was falsified. But when a theory becomes established to where it affects the way we think about our world, where it forms a foundation for our thought in that field, then falsification doesn't really quite cut it. And there's the thing. I mean, we have what's called the standard model in physics, and that's basically the way we currently think of the universe. And in the standard model, we have 97% of the universe unaccounted for. There's part of it we call dark matter, another part of it we call dark energy. And those aren't actual things that we know what they are. They're just placeholders for our gap in knowledge. These are what's called anomalies. Now, that's a pretty big anomaly. 97% of the universe is missing. That's a lot to be accounted for. But we don't have any better theory to explain that 97%. So that's why we stick to the standard model. And we just have these anomalies, and a lot of the more conservative scientists will be like, well, I guess that we'll figure that out and then fill in the gaps. But usually that's not when you have a bunch of anomalies like that, that's not usually how it works. Usually we'll stick to this theory until a new theory comes along that explains both the things that the former theory explained plus the anomalies. And that is called a paradigm shift. A paradigm always explains the previous paradigm plus the anomalies that it couldn't explain. And so I think that's an important insight, because we tend to think that everything that we think we know, is well established because it's that's the basis for example, for a lot of doubt about psychic theory, psychic phenomena, and that I think it's not so much that there isn't evidence for it, because if you read Dean Radin's work, there is a lot of evidence for it. The problem is it doesn't fit with the way we currently understand our universe, and so you can rack up tons of anomalies, but until you have a theory to explain that, along with the things that other experiences explain, then you're just going to stick to what you know. And so it's in that sense that science is rather conservative. There's it doesn't just switch theories whenever some challenge comes to a certain theory. Theories change more gradually than that, and they usually require a new theory to explain. And that, I think, is also what lies at the heart of my sort of back and forth with Piro about metaphysics. Or I'll use Whitehead's term for it, speculative philosophy. Because I think there is, even if you claim you don't have a metaphysics, there is a sort of status quo metaphysics that people assume. And if you sort of offer a different view and say, I think the universe is more like this, and this can explain both what the other metaphysical view explained, plus opens up all kinds of other opportunities, all kinds of other doors, then it expands your thinking. It allows you to think of things as possible that didn't seem possible before. So I guess I'll leave it there for now. Peace.